All right, number 17, we're going to consider the function velocity of an object moving along a line. We're going to describe the motion over the interval 0 to 10, use geometry to find the displacement between 0 and 2, use geometry to find the displacement between 2 and 7, and then assuming velocity remains 10 meters per second for t is greater than 7, the displacement, we're going to find it between t equals 0 and any time t greater than or equal to 7. Okay, so if we look at this function, we'll zoom in a little bit. Again, we can kind of see the velocity is labeled here, meters per second, and time in second. So displacement, when we multiply speed times time, will give us the distance it has traveled. Looks like this object is speeding up for the first second, and then it is constant speed, and then it slows down, starts decreasing, and then it hits a constant speed and stays. All right, so describing the motion, the object is speeding up, starting out on 0, 1, and then it hit a constant speed from 1 to 4, and then it started slowing down 4 to 7, and then it hit another constant speed. All right, now we're going to find the displacement. So I'm going to sketch this image and then we'll be able to kind of draw out the shapes and see what's going on. So coordinate grid, we are increasing, and then we stay flat, start decreasing, and then we stay flat. Now, not exact, but it's going to be close enough. We'll just say that this is 0 to 1, and then this indication happens at 4, and then this decrease stops at 7, and then it goes on to 10. Okay, so here's our general shape. We want to all right, we want to find the displacement from t equals 0 to 2. All right, so I need to go back and write the heights because that's going to be a big help as well. This is a height of 20, and this is a height of 10. I guess I should put 1, 2, 3, 4. There'll be a 5 and a 6 in here, and then so forth and so on. All right, that'll help a little bit better. All right, so we want to know the displacement, basically the area under the curve from 0 to 2. All right, so what we can do, we have a triangle using geometry. So area of a triangle, we need A1 plus A2 is what I'm going to call it. Area 1 plus area 2. This is 2. 0, 1, 2, 3, 4. Okay. So we're going from 0 to 2. We need area of a triangle, which is going to be half base times height. Base is 1, height is 20. Plus the area of a rectangle, which is base times height. Base is 1, height is 20. All right, so we got 20 divided by 2 is 10. So we got 10 plus 20 gives us 30 meters for the displacement from 0 to 2. All right, now we're going to find the displacement from 2 to 7. Okay, so starting from this point all the way to this point. So we get two shapes. So from 2 to 4, we got a bigger rectangle, a distance of 2. So from 2 to 4 is 2. Height is 20. So again, we're going to have, for part C, we'll have two area. We'll call area 2, let's just say area 3 and area 4. We'll leave those be 1 and 2. So the first area, we got a rectangle here, and that is base 2 times height 20. And then the second area, so we're going to 7, so from 4 to 7, this looks like a trapezoid shape. Area of a trapezoid is base 1 plus base 2 divided by 2 times the height. All right, so we'll call this a base and this is a base, and we got this height is 20 and this height is 10, and then the height, the distance 4 to 7 will be our height, and we'll call that 3. So 4 to 7, 3. So we're going to do 20 plus 10 divided by 2 times 3. So we get 30 divided by 2 is 15. 15 times 3 is 45. So we get 40 plus 45 gives us 85. 85 meters. All right, and then now we want to find the displacement from any time between t equals 0 to greater than 7, so going here and beyond. So it told us that this height is 10 every second thereafter. So we need to come up with something. So this part will have already been counted. So we've done the 30 and we've done the 85. So 30 plus 85 is going to be part of that formula, 30 plus 85, because we want the total displacement. This is going to give us 115. Okay, so after here, we need some kind of formula that says when we hit 8, we're going to add 10 and so forth. So we're going to need to add 10t, but we can't just say 10t, because if we're saying t, time will be 8 here, and I only want to add 1. So let's do t minus 7, because when we do 8, we'll add 10. T minus 7 times 10 for 10 meters per second. So 10 is the height. We want to do an additional 10 whenever I count that one. And then, so 8 minus 7 will be 1 times 10, and I'll add to that. So this is a formula we need. Let's simplify it a little bit. So 115 plus 10t minus 70. So 10t plus 45 should get us a formula that will, no matter what we plug in, we should get the time when it's greater than 7. So we're only going to use numbers greater than 7 for this one. So if we were to go back to where we started, this was 115. If I go additional 10 and do 8, we should be at 125. So we can test it. If I plug in 8, 10 times 8 plus 45, gives me 80 plus 45, and 80 plus 45 does in fact give me 125, which matches what I thought it should be. Okay, so we're going to say this formula that works any time after is going to be 10t plus 45.